We are now recording. Good morning again. As I said, thank you for coming to the Systems Approach to Producing Healthy Container-Grown Plants webinar. I'm Janice Alexander. I am coming to you from Novato in Marin County, California. I work for the University of California Cooperative Extension. Hopefully you've been able to hear what I've been saying as I'm coming through your computer speakers. If you have any technical difficulties during the course of the webinar, the best way to contact me so I can help you is to use the chat box down here. We have about 60 people signed up already, so that's great. And we've just been joined by our presenter, Dr. Jennifer Park from Oregon State University. So I want to quickly say thank you to our sponsors, who are the USDA Forest Service Pacific Southwest Research Station, University of California Cooperative Extension Marin, Oregon State University, Golden Gate National Parks Conservancy, and the California Native Nursery Network. And from those last two organizations, we have our third presenter, Elisa Shore, who's also joined us on the webcam to say hello and good morning to everybody. Good morning. So these are the three people you will be seeing during the course of the next hour or so. What I want to say before we get started officially is I want to point out some of the other things you can see on your screen. Over to the right, there are web links that you can look at. While Jennifer's talking, you won't be able to see these, but when she's on Q&A, and right now you can see there's a series of web links, and there's also a series of different documents below that that you can download directly to your computer. Those are resources that will be there for you when the webinar ends as well. Also, I just want to give a quick overview of what to expect during this session. I sent out an email this morning that detailed it a little bit more. Basically, this webinar is going to detail a systems approach to producing plants that are free of disease, and the emphasis being on disease caused by Phytophthora species. It's going to focus on sanitation measures and other issues that are especially relevant for growers of native plants in restoration projects. And the impetus for this webinar comes from the recent discovery of a new Phytophthora species, Phytophthora tentaculata, in California's native plant nurseries. So the general information that Jennifer is going to present will be relevant to all Phytophthora species and other plant pathogens in nurseries. So it's not going to be specific on tentaculata. It will be very broad across all those different pathogens. But additional information is available, as I said, in those links. And you can see up here, just for your reference, this is some of the information. Jennifer will talk a little bit about tentaculata, but it's not specifically on that pathogen alone. So hopefully that sets the stage. If you are expecting something different, feel free to sign off the webinar. If you feel like you can't listen to the whole thing, again, know that it's being recorded and you can catch up at a later time. So that's the background. With that, I'm going to let Elisa say goodbye until we get to the question and answer session, which she will lead with Jennifer. And then I will hand over the slides to Jennifer to start her presentation.
Okay. Janice, can you start that off at the first slide, please? Okay, very good. Good morning, everyone. At least it's morning here in Oregon. Thank you for this opportunity to talk to you about a topic that is near and dear to me, and that is using a systems approach to producing healthy container-grown plants. And as Janice said, this is really addressed mainly to growers of native plants, nurseries producing plants for restoration projects specifically. Now, I am a plant pathologist who's done a fair amount of work with horticultural nurseries here in Oregon, and it is this experience that I'll be drawing upon to talk to you folks that are growing native plants. So there will be a little bit of difference in scale, and but I think we can work with that. So let's go ahead with our first slide. Let's see. All right, so here's the outline for my talk. I want to address why we're so concerned about plant diseases in native plant nurseries. what is the systems approach, what are the most common, what we call critical control points in container nurseries, and then what management practices will help prevent disease. Janice has already mentioned the resources for additional information which will be available at the end of the talk, and there will be time for questions at the end of my talk. So, why the concern? The concern is that nursery plants can harbor diseases that threaten plant health and jeopardize natural resources. And the poster child for this is the sudden oak death pathogen, Phytophthora ramorum. This really called our attention to the pathway between nursery plants and forest diseases, or natural diseases in natural areas. So Phytophthora ramorum was very likely introduced into 2 locations in California, probably on nursery stock, and where the pathogen then spread to adjacent forests. And the pathogen has a very wide host range, as we've discovered. It has been a problem in several horticultural nurseries, and this slide shows the disease cycle in nurseries. The pathogen can come in on purchased plants, for example. The pathogen sporulates on the leaves. It can spread to other plants, causing this foliar blight. Root infection is also possible with Phytophthora ramorum, although it is not the most common site of infection on plants. And spores can wash off into water and serve as a source of inoculum for additional plants through splashing up onto these plants or by plants tipping over into these puddles of water. Potting media that is infested with this pathogen can also be a source of inoculum for causing disease in nursery plants. And in the forest, as you Californians are all too aware, the pathogen creates infections in bay laurel and several other hosts. It sporulates abundantly on California bay laurel. It infects tan oak, which is a very susceptible host, where you get these bleeding cankers that are so characteristic. And of course, there are many other species in the forest that are affected by Phytophthora ramorum. So with Phytophthora ramorum, we have very, very good evidence that it was actually introduced at least 3 separate times. The first time into California in the San Francisco Bay Area, second time into British Columbia or Washington, and the third time into British Columbia or Washington. And this is the result of some very nice population genetics work by Erica Goss et al. So we have direct evidence that this is moving around with nursery plants. You can see that after it was introduced, it was further spread on nursery plants to many other locations in the United States. So it's very serious, and we want to prevent that pathway from nursery plants to natural areas. Well, unfortunately, there are several other examples of Phytophthora species, exotic Phytophthora species, that are most likely spread from nurseries to wildlands. In fact, in recent years, there's been a whole plethora of outbreaks that have been more or less directly related to contamination of nursery plants. The first, probably, at least that was well noted, was Phytophthora lateralis. This is a pathogen that causes Port Orford cedar root rot. And as early as 1925, this was observed in nurseries in Oregon. And unfortunately, now it's causing widespread disease in native stands of Port Orford cedar in Northern California and Southwest Oregon. And more recently, it has jumped to nurseries in Europe and is causing disease in hedgerows and forests in France and the UK. A second example would be Phytophthora alnii, subspecies alnii, which is a pathogen of alder. And there is good evidence that, again, this pathogen started out in nurseries, reforestation nurseries, and then was spread through the planting and through waterways from those nurseries to forests. Phytophthora kernoviae is a fairly recently discovered pathogen. It was found first in New Zealand. It is present in the UK and has a wide host range, again, spread most likely from nursery plants onto beech trees and some other hosts in Europe. Phytophthora cinnamomi has been on the West Coast and really many parts of the world for quite a while, but it has been moving into wild areas with increasing frequency through the spread with nursery plants as well as foot traffic. It's moved very easily in soil, and Ted Zwicky has done some excellent work on Phytophthora cinnamomi disease on Arctostaphylos and Arbutus chinkapin and other native species. Phytophthora tentaculata is the pathogen du jour in California native plant nurseries right now. This was first reported quite recently by CDFA. It was the first report in North America, found first on Mimulus or Diplacus aurantiacus and toyon, and some other species, a few other species, in nurseries as well as in landscapes where it was outplanted for restoration. And just day before yesterday, a new report came out on Phytophthora occultans, which was reported for the first time in North America from a native plant nursery in Oregon on Ceanothus. And subsequently, this same pathogen was identified in horticultural nurseries in Oregon on boxwood and rhododendron. So there's a real smoking gun there indicating that this pathogen also originated in the nursery trade. This pathogen also occurs on boxwood in Europe, by the way. Here are some examples. This is Phytophthora lateralis, cause of Port Orford cedar root rot. Phytophthora alnii, subspecies alnii, causes alder decline in Europe. Phytophthora kernovia, this is on beech in the UK. This is a slide from Ted Zwicky showing Phytophthora cinnamomi infection of Arctostaphylos, California. And here's a picture of a Mimulus or Diplacus aurantiacus in California infected with Phytophthora tentaculata. This is the new species just reported in North America, Phytophthora occultans on Ceanothus species. You can see on the left are plants. These were inoculated plants, inoculated with the pathogen. This is the healthy control. Same here with the infected plants and the healthy control. And these plants were unfortunately, or one similar to these, infected plants were outplanted on restoration sites. Now, those are not the only pathogens that are found in native plant nurseries. Recent research by CDFA and also Ted Zwicky and Laura Sims and others have shown that native plant nurseries harbor other Phytophthora species, such as Phytophthora nicotiani and Megasperma. This is another picture of Diplacus that is infected with another Phytophthora species as yet identified. Here is another photo from Laura Sims showing infection of Ceanothus by Phytophthora cactorum. And these are nursery-grown toyon that are infected with Phytophthora cactorum root rot. And it's very interesting that these plants, really the above ground parts of these plants, are not showing severe disease symptoms at all. Phytophthora cactorum does cause root rot on a wide variety of plants, but interestingly, you don't really see the symptoms of disease unless you look carefully at the root system and you see a lot of rotten roots. And as Ted Zwicky has pointed out, many of these native plants that are drought tolerant seem to withstand a fair amount of root rot if they're receiving a fair amount of water in the nursery, but once they're outplanted and subjected to drought stress, they don't survive. So infested native plants that are produced for restoration have the potential to deliver some extremely damaging pathogens directly to new habitats and hosts. And that's why we're so concerned about their health. Let's review just a little bit about Phytophthora so that we understand better why it is such a potentially damaging pathogen. It's marvelously adapted for a number of different kinds of environmental situations. First of all, it produces either oospores, or in some cases oospores and chlamydospores. Anyway, two types of thick-walled spores that are quite tolerant of desiccation and heat. So these can stay in soil and in roots and in plant debris for a very long time. Under conducive conditions for disease, these propagules can germinate to form sporangia. These are the structures which release the swimming spores, the zoospores, which makes this a very interesting pathogen to work with. These zoospores are attracted to plant roots and plant other surfaces, and where they insist on the plant surface and then germinate and penetrate the plant tissue. Now, Phytophthora is not a fungus. It is considered a water mold, and it's called a water mold because part of its life cycle, this one right here, is dependent on the presence of free water for these zoospores to disperse and complete its life cycle. So you've got survival structures, and we also have dispersal structures, and these dispersal structures are require water to move around. Now, no self-respecting plant pathologist could give a talk about disease without talking about the disease triangle. And it's a very important concept to understand. The disease triangle really shows that you need three elements in order to cause disease. You need a susceptible host, you need a pathogen that is virulent, that is capable of causing disease, and you need an environment that is conducive. And only if you have all three elements functioning at the same time will you see disease. What's so insidious about the nursery-grown plants is that you may have a limited range of hosts in the nursery. You may have a pathogen, but it's not until you have a conducive environment until you actually see disease occur. Or it may be that you have the virulent pathogen in a conducive environment, but not the right susceptible host. However, when you move this to a reforestation site, for example, where you have a whole array of new hosts, that is where you may first observe disease. Nurseries, native plant nurseries, are not the only nurseries that are problematic. We recently completed a study of Oregon nurseries, 4 Oregon nurseries, in which we found 28 different Phytophthora taxa, and some of these are really would be of great concern if they were delivered to forest situations as well. But in doing this work, we applied a systems approach to try to determine where the source of contamination was in the production cycle. So, for example, we looked at potting media ingredients, used containers, irrigation water. We looked at soil and gravel, and we looked in water. And so that has really informed my approach to looking at disease in native plant nurseries as well. Well, what is a systems approach? There are many different definitions, but the one I like to use is that a systems approach considers the entire system of plant production from start to finish. And it identifies the greatest hazards of contamination by plant pathogens. And these points of greatest hazard are called critical control points, or CCPs. So critical control points. So this is also the best stage at which to mitigate that contamination hazard. And by knowing what those critical control points are, it's possible to develop and apply management strategies which will correct the unsafe practices in the nursery to reduce the risk of disease. I see there's something a little funny going on with this file, Janice, but I'm not sure there's anything you can do about it. Okay, so if our goal is to produce healthy plants, and of course it is, we can use a traditional approach, which is to produce the plants and then test any at the end that are symptomatic. And that's essentially what is done in traditional endpoint testing. It is very much a reactive strategy, and it's based on our ability to detect plants that are diseased. And in contrast, a systems approach is aimed at correcting unsafe practices in the nursery, and there needs to be some way of ensuring compliance with these management practices. And one way of doing that is some type of certification process based on compliance with those best management practices. It's very much a proactive strategy, and instead of relying on detection of diseased plants, the strategy is based on prevention. And we might think about how this is utilized in something familiar like restaurants. When you go to a restaurant, you expect that the food you eat is safe to eat. And yet, every meal that comes out that kitchen door has not been tested for foodborne pathogens. Instead, that restaurant is certified by the local public health department as having practices in place that prevent contamination of foodborne pathogens. For example, meat has to be refrigerated at a certain temperature. The dishwasher temperature has to be a certain temperature. All of those are best management practices which ensure that the food coming out is in fact safe for you to eat. So what we're talking about here is using a similar approach, but for a different product, and that would be plants. So first thing we want to do is think about a flow chart for native plant nurseries. And this is a kind of a generic flow chart. I'm sure that there are many variations on this theme. But essentially there are elements that take place off-site of seed collection and collecting cuttings for propagative material. These plants are up-potted maybe one or more times. Perhaps they go into a field situation. At the time they're sold, they might go directly to outplanting, or they might go first to a holding nursery. And of course, there's also an opportunity to buy in plants from other nurseries. So we're going to talk about each of these boxes, plus a few more. Let's talk first about seed collection and cuttings collection. So this is occurring off-site, and you want to make absolutely certain that when you are collecting this plant material, that you clean tools and boots and gloves both before you go to the field and after you go to the field. So you are not conveying pathogens back and forth between the natural area and the nursery. You want to make sure that you're selecting plants from non-infested areas. You want to be using new envelopes for those seeds, clean bags, new bags for those cuttings. You want to keep very careful records of where you are collecting this material in case any problems develop later. Propagation is a critical stage where sanitation is the rule. So this is a real situation where cleanliness is next to godliness. So you want to make sure that those cuttings are disinfested. You want to make sure all your containers and stakes and labels are new or disinfested. And we'll talk about specific details in that in a moment. You want to use absolutely clean potting media or pasteurized soil, clean water, disinfested tools. You want to ensure good drainage. You want to make sure there's no contact with any kind of contaminated surface or soil. You want to disinfest between lots of plants and scout for problems early and often. Dispose of unthrifty plants. Limit access to only those people who really need to have access. You don't want crowds of people coming through your propagation facility. You want to use foot baths at the entries to keep soil and other plant debris from being tracked in. And again, you want to keep really careful records. Let's talk about plants purchased from other nurseries. It's really important that you know your source and that you buy only from nurseries that you also believe to be clean and utilize best management practices. You should always inspect the plants when they arrive, keep track of their source, and especially important is keeping these in a separate area for several weeks before you intermingle them with your own stock. So put them in quarantine so that if a problem arises, it has not contaminated your entire nursery. You're going to want to scout for problems and keep careful records. Up-potting requires the same kind of diligence, actually not probably as much diligence as your propagation stage, but you still want to make sure that you're using newer disinfested containers, clean media, clean water, disinfested tools, and again, no contact with any contaminated surface. At the holding nursery, now the plants may only be there for a short time, or maybe they're going to be there for a long time before they're ready to be outplanted. It's very important for that holding facility to keep track of the source nursery for each individual lot of plants so that plants are not intermingled with one another. That is so that if a problem develops, the problem can be traced and it hasn't contaminated all of the other plants. These plants also need to be kept free of contamination while they're in the holding facility, and this facility needs to be disinfested in between lots of plants. And finally, at outplanting, it's very important to keep these lots of plants from different nurseries separate and to use very clean boots, gloves, and tools, or to clean them both before and after any type of outplanting. Make sure that any additional mulches or compost are free of pathogens so that you're not introducing pathogens at that very late stage with contaminated materials. Do not ever allow plants or pots back into the nursery after they have been at an outplanting site, and never send plants or pots from one nursery back to a different nursery. These plants, once they're in the ground, they need to be scouted frequently for problems, and of course, good records need to be kept. Well, some very important other considerations in this production flow chart would be some inputs shown here in these yellow boxes: the potting media and soil, the water, and the pots. And there are some outputs from most nurseries in the form of cull plants. If they're healthy, they can be used to make compost. And when I say compost, I mean really composted to achieve the high temperatures that are necessary to kill any plant pathogens. If they're showing any symptoms of disease, they should not be placed in your normal cull pile, but they should be disposed of either by going into a landfill or deep burial. Okay, so now I want to lead you, or introduce you rather, to this systems approach manual that was put out by several of us a few years ago through the Oregon Association of Nurseries. This booklet is available for free download, and the website is given there. It's also available as a PDF in the extra resources area. And I'm going to show a few pages from this book in the next few minutes. So this book utilizes a systems approach for nurseries and breaks it down in terms of site selection, that is nursery site selection and maintenance, plant procurement, propagation and greenhouse production, water management, container production, etc. And we're going to go through some of these. But one of the things that you might do if you're evaluating your own nursery is to use this book and go through the checklists that are available for each of those different components and identify whether or not you are likely to be having some contamination problems at this particular stage of production. So for example, for site selection, is your site isolated from known or likely sources of pests and pathogens? So you can check either yes or no. If the answer is yes, you're in good shape. If it's no, you will want to look at some of the best management practices that will help you reduce the contamination hazard. So I don't have time to go through each of these questions. You can do this on your own. It's a way of self-identifying the most likely sources of contamination and risk of getting disease in your nursery. Here's one for plant propagation. Here's one for water management. So I want to now breeze through some photos showing you some of the most common critical control points in nurseries and their corresponding best management practices. So site selection. This is a lovely nursery, native plant nursery. Unfortunately, it is surrounded by sudden forest infested with sudden oak death, and plants that were produced in this nursery, many of them were also infested. These are some bay laurel seedlings. They were actually placed right underneath an infested bay laurel tree in the nursery. There were also some coast live oak seedlings that were planted under this tree, and you can see lesions caused by Phytophthora amorum on the tips of these bay laurel leaves. So customers who purchased these plants unknowingly transferred them to their own homes and spread spread Phytophthora amorum to their own yards. Propagation. This has to be the cleanest part of your operation. There's an excellent paper written in Australia by the Nursery and Greenhouse Association. This is available as a PDF. It talks about the need for scrupulous hygiene at the propagation stage. And you definitely want to make this the cleanest part of your operation. Here are some women that are propagating from cuttings. This is a bath that has a low concentration of a disinfestant in it, and tubs of these cuttings are dunked into this disinfestant before they are stuck. This is actually a rooting hormone, so it's not disinfestant, but this water is changed out frequently so that if there's anything on the surface of these cuttings that are brought in from outdoors, they are disinfested before they're used for propagation. What can you use for treating cuttings? Hydrogen dioxide is one, and chlorine dioxide is another that is effective. You have to be careful about phytotoxicity. With many of the native plants, we don't really know the best concentrations to use. Note that xeritol is labeled for use on ornamental plants as a pre-plant dip and a foliar spray, and chlorine dioxide is labeled in the vegetable and fruit processing industry. So these are materials that really don't have any residual. They're simply a disinfestant, but they're safe to use on most plants. You want to make sure that the area where you're doing your propagating is an area that can be cleaned very thoroughly, preferably something like a stainless steel bench or a hard impermeable surface. For cleaning those hard surfaces, you have a variety of materials that can be used. For best results, you want to clean these free of soil and plant debris first, and then apply the disinfectant. And you need to use them at the labeled rate and the minimum contact time. So here are some of the materials that are useful: peroxides, quaternary ammonia, good old bleach, and Lysol, actually, depending on the formulation, has several different active ingredients in it. So this is an ultra clean propagation house. This is in a large commercial horticultural nursery. In this nursery, their sanitation practices are so good that they don't use pesticides for plant disease, which is pretty impressive. Now, it's hard to achieve on a smaller scale, but it's not impossible. Here's a native plant nursery who actually maintains very good, clean, pretty clean, very clean actually, conditions by using new trays for propagating and placing them on these bench tops made of wire. So it is possible. They also have the fabric on the ground to prevent splashing, and most importantly, these are up on benches raised up off of the ground. You don't see a lot of leafy debris here either. So the kind of surface that you set your plants on is very important. Something like stainless steel can be not only can it be cleaned very well, but it's not very hospitable to plant pathogens either. This is some work by Warren Copes in which he just showed the survival of plant pathogenic spores, in this case of Botrytis cinerea, on different kinds of materials. And the important point to note here is that spores survive very well on untreated wood, whereas on impermeable surfaces they survive less well. And then again, untreated wood is virtually impossible to disinfest. Here is a bad example. Here's a greenhouse where there are lots of little trays for propagating plants, but it's in a bed of vermiculite. And when the roots go down into this material, they take the pathogens with it, and the pathogens remain there to contaminate the subsequent crop of trays that is placed on it. Let's talk about where you place these containers. You do not want to place containers directly on the ground where there's splash up from soil, causing, in this case, Phytophthora disease. Whatever you do, get them up off the ground. These are up off the ground, but then again, they are on some old pallets of rotting wood. This would be impossible to clean. You can see that soil accumulates on this material, and it does not doesn't help very much. Here's some other bad examples of of containers that were placed directly on the ground in contact with soil and in water. Much better if you can place them up on a bench, preferably with some floor that can be cleaned. This is not bad. They're at least using new pallets, which are switched out after every crop. And they are up off the ground. You can make a barrier with other containers, put a layer of rock or gravel to prevent splash dispersal. But the higher up you can bring those containers up off the ground, the better off you're going to be. This is my preferred method, actually. Up off the ground. You want to also make sure that you're not placing your containers in contact with leafy debris, because these leaves can harbor pathogens. Much better to place them on a surface such as this fabric mesh, which can be cleaned in between crops. Water management. For Phytophthora being a water mold, is critical for reducing disease problems. You never want to have standing water in your nursery where the pathogen can be splashed from puddles to adjacent plants, or they can actually swim to the bottom of the containers and go up and infect the roots that way. And of course, any plant that tips over into this puddle is absolutely doomed. It only takes about 10 seconds for that foliage to become infested by Phytophthora if it's present. Absolute no-no. Here's kind of a creative solution for creating a drainage channel after the plants were actually set on the ground. This channels the water and allows the site to drain. If you can utilize a slight slope, that's very helpful. And if necessary, you can even engineer the site, as this nursery has done, to promote good drainage. Now, I'm not going to talk about treatment of irrigation water because, as I understand it, most of the native plant nurseries are on a municipal water source, and so that water would be free of Phytophthora. But you can pretty much assume that any surface water, such as rivers, creeks, or reservoirs, are going to be contaminated with Phytophthora, and that water would need to be treated. So I'm going to skip over this ways to disinfest irrigation water. But know that that would be a problem if you were using surface water as your source of irrigation. Okay, soil and potting media. Soil is loaded with microorganisms, and most of them are good guys. But some of them are not. Some of them are plant pathogens. And the principles for treating soil, I learned from Kenneth Baker, a professor of plant pathology who was at UC Berkeley until he retired and came up to Oregon. And he was a mentor to me when I was a graduate student. And back in the 1950s, he wrote the UC System for Producing Healthy Container-Grown Plants, and followed that by 2 more books on biological control. But in this first book in 1957, he showed that it is not necessary or desirable to sterilize soil used for growing plants, that there are beneficial organisms in that soil that can be retained if you treat the soil instead at a temperature which will kill the pathogens, but allow the other organisms to remain alive. It's very interesting. Now, this says most plant pathogenic fungi, bacteria, and viruses are killed by 140 degrees Fahrenheit for 30 minutes using aerated steam. Pythium and Phytophthora are even wimpier. They are eliminated by about 45 degrees 45 degrees centigrade, or 112 or 15 degrees Fahrenheit for 30 minutes. You can make use of this then in treating your soil. Don't think I have time to explain this. I show that it's now 10:45. Um, I'll explain, however, that he showed that plant pathogens have a much easier time reinfesting soil that has been sterilized than when it has been treated at a lower temperature. So ideally, you retain those organisms that are suppressive to plant pathogens while also eliminating the plant pathogens. You can do this with pasteurizing in a steamer cart. You use a generator and an aerator to bring the temperature to 60 degrees C for 30 minutes. You can also use soil solarization, especially in California. And in order to kill most soil pests and pathogens in the top 6 inches of soil, you want to aim for a temperature of 110 to 125 degrees for 4 weeks. There's an excellent PDF on how to do this through University of California IPM notes, and that PDF is available after after the webinar. Those of you that are in coastal areas this may not work for you because of the areas of coastal fog, but those of you that are in the Central Valley or in many other places in California, solarization may be your new best friend. We have also done work on solarization in nurseries and found that it works extremely well for killing Phytophthora. And we've discovered that using a type of plastic called anti-condensation film increases the heating relative to regular film by quite a bit. I think I have time to describe that. This shows a type of solar tent construction that can be used for both soil or pots. Again, this is available in that PDF on soil solarization. Now, if neither of those options for treating soil is going to work for you, you can purchase bagged soilless potting media. And if you want, you can add inoculum of mycorrhizal fungi or biocontrol products to those commercial potting media. You might also want to prepare your own media from raw materials, but you have to make sure that they are free from pathogens. So bark, compost, and sand all would need to be free of pathogens. Pumice, vermiculite, and perlite are typically free of pathogens. Let's see. If you are making your own potting media from raw ingredients, make sure they're stored on an impermeable surface, that they do not get contaminated. Don't do this. Don't drive your equipment through the same area where your media are stored. I'm going to need to wrap up in just a couple of minutes here. Treatment of containers, extremely important. There are a couple ways of doing this. You can steam them. You can wash them to remove soil roots and organic debris and then soak them in either a hot water bath or in a disinfestant, or you can solarize them. So there are a couple different ways people have discovered for steaming pots. Here's a mobile steam unit. Here's a nice little unit for steaming pots. Here's the hot water dip. You can also solarize. So if you can't do any of those things and you're left with a bunch of infested pots that you cannot clean, there are companies, at least in the Northwest, where you can recycle these pots. They will come and pick them up, grind them up, and melt them into plastic, into new pots. So I'm going to wrap it up in just a second. I do know that there is a hands-on workshop given in June where Kathy Costa will be talking about scouting and monitoring for pathogens. And so I will be, fortunately I'm out of time and can't really talk about that very important aspect here. I just have to point out that you need to be following the health of your plants. You need to know what a healthy plant looks like. That's one on the right. And you need to know what they look like when they're beginning to get sick. This is a Phytophthora root rot. And if you take those plants out of the pot, you see very clearly the difference between healthy roots and the brown rotten roots of the diseased plants. So know the plant material that you're dealing with. I don't have time to talk about the diagnostic kit, but again, this will be covered in the workshop on June 16th. This is an ELISA diagnostic kit that you can purchase to determine if Phytophthora is present in your plant tissue. I think I'll skip over this. So hopefully you have an idea of how a systems approach can be used to help you identify sources of contamination in your nursery, and you have an idea of the best management practices that can be used to minimize the risk of disease in your nursery. And with that, I will just flash by some other resources that may be of use to you. This booklet is geared towards Phytophthora ramorum specifically, but the best management practices in it will be very useful for other Phytoptheras. We also have a free online course here at Oregon State University. It consists of 3 different modules. To learn about the biology, symptoms, and diagnosis of Phytophthora, disease management, and there's a special module
on so much, Jennifer.
Phytophthora ramorum. So I think we'll
stop
Jennifer,
there, that was wonderful. Thank you. I am really looking forward to continuing this conversation. And for folks who need to peel off, you're welcome to peel off early. But for people who can stay on the webinar a little bit longer, we're going to take additional time after 11 to continue to answer questions. So you're welcome to continue to write questions in the chat, and I'll try to do my best to pass these on to Jennifer and have her follow up on the questions that are being asked. So I just wanted to say that I think everybody who's involved today is really is sharing an ethic of growing healthy container plants, and that's why we're prioritizing our time. So with that said, I'd like to ask some of the detailed questions that came up just with respect to the people who are on the webinar to make sure that their questions get answered, but I'll also ask a few general questions that might not have been included in the chat yet. So, so to start off, I just wanted to ask about there was a question about disinfesting plants. My understanding is that disinfesting cuttings is a possibility, as you described, but that disinfesting plants themselves is probably not practical, and plants that are diseased should be disposed of. Is there anything else to add?
Yeah, that's right. Yeah, you're absolutely right, Elisa. The disinfestant was really meant just for as a precaution.
And then
for when you're bringing
getting a little bit more broad, this was specific to a question about disinfesting cuttings. What resources are out there
for an entire plant?
Protocols and resources for the use of sanitizing chemicals and disinfectant solutions? You've mentioned a few in the presentation. I'm wondering if there are any resources that people could specifically download, find, and have very specific detailed protocols for disinfesting tools, pots, and any materials that they use.
Right. Right. So um, the, the PDF I mentioned from Australia has a very excellent section on disinfestants. And there are two publications by Warren Copes, which I could make available to you. One is through the Plant Management Network, and one was published in Plant Disease. And so Warren Copes tested chlorine dioxide and hydrogen dioxide on several different plant species for use on plants. And then he tested a bunch of different disinfectants on surfaces. That's a separate publication. So
I think those would be really
hard
helpful.
to summarize that
just
easily,
understanding
but
that there's a distinction for disinfecting
that information
different
is
things.
available, and
I'll
more talk to Janice
there's a
about
value to having
to make
maybe
those
multiple
publications
tools
available
in the toolkit.
to the group. Right, and I guess one point I'd like to make is that if you may not want to use toxic materials, but if using a disinfectant with no residual for very short-term, killing of pathogens, if you do that and use scrupulous sanitation, it actually allows you to grow your plants without other pesticides later. So it's a really, in my opinion, a very good investment.
So speaking of proper sanitation and proper setup of a nursery situation, if people have their plants on raised benches and those benches are made of wood, is there concern that those benches themselves, the framing of the benches, could be harboring Phytophthora if they're made of wood?
Yes, there is that potential because wood cannot be cleaned very well. There are a couple of, if they're solid wood, I'd say it needs to be replaced or at least covered with even a plastic that can be cleaned.
Okay.
I
want to
on the other
go
hand,
to
if it's a
some
wire mesh supported by wood,
question.
it may be that by
You're really
placing the
encouraging
containers
a
on the
systems
wire
approach
mesh
today,
part of
and
it,
I
so
think
it's not in
everyone
direct
is getting a
contact with
view
the
of what that
wood,
means and has a
that
lot
is
of
a pretty good
resources to
compromise.
follow up on the details of a systems approach and looking at critical control points. For nurseries and growers that have very, very limited resources, what do you think people should tackle first? What are the most important steps and most important considerations to take on initially if a nursery might need to do a course of action over the long term, or simply doesn't have the resources for purchasing the types of equipment or material that's being described to maintain a really, really high level of sanitation and have the equipment to, let's say, pasteurize soil or buy new pots regularly? If the resources are limited, where should people start?
That's a hard one because there's so many different sources of contamination, but I understand the problem, and resources are limited for most people. I would say most important thing would be to start with clean potting media and clean pots. They don't have to be new pots, but they have to be clean. And if you can keep them off the ground, that's extremely important. It does a couple of things. It prevents the contamination from the soil. It promotes drainage. So those things would be really important. And solarizing is a really good technique for people, in many different areas of California and even in the Northwest. Entire greenhouses can be closed, for like a few days even.
There's also a question about
the entire greenhouse would be virtually
buying compost or soil or other materials from commercial
during the hot part of the
providers.
summer.
Do commercial providers
even
have
on a smaller
any
scale, it can be done
standards which they follow or
soil.
testing regimes which they follow that would make that provider a reasonable or a good source to purchase from? How do people vet the sources for potting media or compost if they're not going to be able to potentially pasteurize their own soil on site?
Well, that's a really good question. I'm not sure how it works. I think it's important for growers to contact the supplier and actually find out what the methods are. Is the compost really composted? If it is, then it's going to be free of plant pathogens. But you want to make sure that it really has met the state standards for composting. You want to know what the source of bark is, for example. The potting media that comes in bags is almost universally pasteurized or made from raw materials that are free of pathogens. But I would say it would be a good idea to double check.
Okay, great. And
I'm not familiar with all the suppliers of that bag material, but it is really a pretty good option, for most growers. I will say this, that the bag material is often very high in nutrients and may not be ideal for growing native plants. And so, in that case, it may be important to begin with your own raw materials and make a well aerated potting medium, but it is not so high in nutrients. But there are commercial.
Great. So I just want to do a time check for people who need to peel off now that it's a couple minutes after 11, and we're just going to continue
especially
talking.
outplanting.
And again, the session is being recorded for people who can't stay or for people who would like to view the session later and recap some of the items. So another general question that I'd like to talk a little bit about is in the form of a way that growers can communicate with their buyers and their clients that they are doing a good job of growing healthy plants. And I don't know whether you'd feel comfortable with growers establishing a certification program that says the word Phytophthora free, but what are some ways that you think growers can work towards saying confidently that their plants are healthy to clients and have people be able to understand that as that their methods are sound growing methods and clean production?
Well, what I would suggest is that your group of growers develop, come to agreement on a set of practices that will minimize the chance of plant diseases occurring. And you'll want to develop this set of practices in consultation with the very excellent people that you have at CDFA. And agree on this set of best management practices. And if the growers then comply with these practices, they could put essentially certify that they were grown under that set of practices. And you can't say with 100% confidence that every single plant is free of phytophthora, but you can say that they were grown in such a way as to totally minimize.
I have two follow-up questions in that case. The first is, could you elaborate on when to do testing and with what regularity
that could
testing
be
should
actually
be done? I know we
supported
didn't have a lot
by
of time to cover
some
that. But that's one
testing as
follow-up.
well.
And then a second follow-up question that's related is you described the necessity to know your source if you're buying in material. And I'd like you to elaborate on the quarantine times and how long plants that are purchased from another source should be held in quarantine, and if those quarantine times are effective, and how to really, before you start intermingling into the existing stock, how can people be confident that the plants have been through a sufficient quarantine period?
Okay. So for knowing your source, I would say go visit the nursery and look at their sanitation practices. You know, if you're buying from another nursery, I would say really get to know what they're doing and make sure that you know, it's as clean as your nursery. And you don't want to bring in somebody else's problems and jeopardize your own material. In terms of how long to quarantine the material, it is hard to say, but several weeks would be a good thing. Of course, many pathogens do take longer to develop, but normally it's not practical to keep.
There was a question about water that's held in cisterns.
For, you know, months or
I'm wondering
years.
if you
So
can
some
talk about
reasonable
if that
compromise
would
of
have
several
the
weeks is
same
probably
concern.
fairly
If
good.
reclaimed water held in cisterns, if that has the same concerns for you as water that's held in ponds and recirculated.
If the water in the cistern came from runoff, if it wasn't, if the water in the cistern came from the nursery itself, then it's going to need to be treated before it's used for irrigation. If the water in the cistern is clean, I mean, it came from a municipal source, it just simply storing it in a cistern is not going to contaminate it. I'm not sure I'm quite answering your question. The source of the contamination is going to be from runoff. So it just depends on if that cistern is linked up to the runoff or not. There are things that can be done to that water. Let's just say a nursery is recapturing their water, and of course there's a huge impetus to do that because water is in such short supply. And I'm working with a lot of nurseries on recirculating 100% of their water. And a small scale, something that would work really well for a nursery would be slow stand filtration. Very, very effective. It just doesn't handle huge volumes of water and therefore isn't practical for large horticultural operations. But Lauren Oakey at UC Davis has done a lot of work
moving on a little bit
slow
to talk more
sand
about
filtration
testing.
as a way of disinfesting
The ELISA test kit that you referenced, would you recommend that as the most inexpensive and effective way to test? And should testing only be done on symptomatic plants? Should it be done on plants that seem to be healthy? And on what timetable, at what intervals should testing occur?
Well, let me see if I can tackle this one at a time. I mean, the testing itself would be a good hour-long talk, and actually, I believe that Suzanne and Cheryl are going to be talking about this during their hands-on workshop. But just to answer it in a fairly short way, the AgDia kits, to my knowledge, are the cheapest kits to use. About, I think, $5.80 a kit. depending on how many you buy. I use it on mainly, I would say first, if you have symptomatic material, test it on that. So that could be on leaf material that's showing symptoms, or you can use it on roots and crowns of plants that are showing symptoms of root rot. The problem is that, as shown with that Toyon photo from Ted Sweeky, you can have plants that are infected that are not showing symptoms. So if you have enough money and time to be testing lots of plants, then sure, it'd be great to test the asymptomatic ones as well, but I would probably prioritize the symptomatic ones first. Another way of testing that I didn't get to talk about, I had some slides there but didn't have time, is a non-destructive baiting method called the leaf in a pot method. And this was developed by colleagues in Europe who found that if they took in this case, rhododendron leaf, although you could use other leaves, that had not been treated with any fungicides and was free of pathogens itself, you put it in the bottom of a pot that contained a plant. So in other words, you lift out the root ball, place the leaf inside the pot, replace the plant, and then set the whole thing in a saucer of water so that leaf bait is submerged for 3 to 5 days. You can actually bait any Phytophthora that is present associated with that root ball. And so what you would do then with that leaf bait would be to send it into a diagnostic lab to determine which Phytophthora species, if any, were in that leaf bait. So that is another possibility. The problem with the kits is that it's only genus specific. That is, it'll tell you if Phytophthora is present or not, but it won't tell you what species is present. And there are some species of Phytophthora that, as far as we know, are saprophytic. That is, they don't cause plant disease. So it will pick up those. It will also
pick up some. I'm going to ask a couple of pretty specific questions. But, there's a question about
if you have a lesion on a plant leaf and you want to know if it's Phytophthora or not,
plastic pots.
That is a really good starting
place. I wondered if you had any feedback or thoughts on that. And also, you mentioned using mycorrhizae in soil as a beneficial. And since we're a community of native plant growers primarily, there's a question about whether that's appropriate, whether the introduction of these mycorrhizae is appropriate for native landscapes. I'm wondering if you have a thought on that as well.
Okay, so first for the fiber pots, I don't have any direct experience in working with them. What's nice about them is that, I mean, if they're new, then they're going to be free of pathogens, and that's a good thing. I don't know of any reason to think that they would be worse from a disease standpoint whatsoever. I think the benefit is if you can start with something, a new fiber pot, that's great. Not sure that was the actual, if that was all the question or not. In terms of mycorrhizae and native plants, this is a real dilemma, as we all know, because many disturbed sites are lacking in mycorrhizae, or very depauperate in mycorrhizae, and native plants that are dependent on mycorrhizae for growth often do not establish or survive well on those sites. But the question is, do you inoculate those plants, perhaps not with the exact same spectrum of species that might be on that site ultimately? And my feeling is that, at least with the arbuscular mycorrhizal fungi, that there's so little host specificity that I would think the benefits drastically outweigh any negative aspects. That by using a cocktail of a different species, a blend of different species, then the one which is favored by that environment ultimately will survive and thrive the most. With ectomycorrhizal fungi, there is a little more host specificity and adaptation to particular sites, but I think often what happens is that when you put a plant out there that's mycorrhizal with something from a nursery, the species on those roots are eventually replaced by the native population, but you give the plant a chance to grow long enough that it has roots that can be colonized.
Okay, great. And but that's my personal preference. With one final question, because
I can see why there would be a concern about that.
The question is, given the disease triangle that you elaborated on, I'm wondering if there is some sense or benefit to nurseries being very, very careful about which plants they decide to grow, meaning that if plants are known to be hosts, what's your thought on nurseries that might decide not to grow those plants so that host plants aren't a part of the nursery environment? At least it would reduce the risk. I know there's many, many plants that might be hosts that are unknown to us as of yet. But if there were a comprehensive list of known host species for Phytophthora, would you recommend that as a possible approach, just to kind of break up the disease triangle and not have as much potential for harboring the disease on host plants?
I certainly think that is that's the control tactic of avoidance, and that is an excellent idea. If you don't grow a susceptible host, you're not going to have disease on that host. I think that makes a lot of sense. And for example, in that native plant nursery that I showed at the beginning of my photos, they could have continued as a nursery growing non-hosts for Phytophthora ramorum. And that might have been fine. But if a nursery is not capable of growing very susceptible hosts without.
And would you recommend a resource list for Phytophthora hosts?
Of disease? I'd say better not.
I know it's growing. I know that we're still learning as we go, but I'm wondering if there's somewhere that people can start. Mm-hmm.
Let's see. I can think of a couple of different lists, but mainly for horticultural plants, and I cannot think of a list right off the bat. Maybe others in California would know better about this. A list of susceptible native plants in California.
Yeah, and
it'd be nice to develop a list like that.
For sure.
We know quite a few of them.
Well, I'll end the questions there.
That's something
Thank you
where
very,
your
very much,
association
Jennifer.
could really help.
And I suppose if some other questions come through the chat now that we're wrapping up, I'd be happy to forward those questions to Jennifer and get the questions answered offline.
That's perfect. Thank you, Elisa. That's exactly what I was going to say. So we are going to end up the webinar now, and thank you very much to Jennifer and Elisa for helping present today. And all of the links that Jennifer mentioned during her talk are available in these pods to the right-hand side of the screen. And I will be putting the recording link up there as well as sending out an email to everybody with the link again to this room, the link to the recording, and a link to an evaluation survey. So I appreciate everyone's time today. I hope you found it worthwhile. And with that, we will sign off. Thank you very much. Goodbye.